All right, today we're going to learn to solve quadratics using square roots. And our essential question is, in the form ax squared plus c equals 0, how can we determine the number of solutions? So we have 4 examples we're going to be focusing on in this video, and we need to find the numbers of solutions. Well, we'll find 2 solutions to each of them, but in particular, we need to figure out how we're going to get to those solutions. And it's important to distinguish between the 2 different types of problems we're going to be faced with today. In our first one, this notice is different than what is presented in our essential question. Our essential question has an x squared term and a constant of c equal to 0. This has an x squared term and an x term. These must be solved using different methods. For the first one, unfortunately, we must solve by factoring. Thankfully, however, this is just about as easy of a problem to factor as you can get, as we only need to find our greatest common factor. And our greatest common factor of x squared and negative 9x, well, the only thing they share is an x. So I'm going to divide each of them by x. The x comes out since we're dividing it. And x squared divided by x, well, x squared is like x times x. X divided by x is 1, leaving us with a single x. And then x divided by x again is 1. 1 times negative 9 is negative 9. So we're left with x times x minus 9 equals 0. From here, each factor is set equal to 0. So x equals 0 is our first factor. X minus 9 is our second factor. In order to solve for x and x minus 9, we need to add 9 to both sides, yielding x equals 9. Of course, the reason why these solutions can each be set equal to 0 is because if x here equals 0, it doesn't matter that this is x minus 9. The whole thing ends up being 0. And likewise, if we plug in x equals 9, we have a 9 out here, but this becomes 9 minus 9, which is 0. And 9 times 0 again is 0. So that is why we can split this into 2 problems and solve each factor individually. Now, example 2 is pretty much the same problem again. And the only difference this time is that it is not already conveniently set up so that it says equals 0. So unfortunately, we have to do a little bit of work ourselves. So I'm going to begin by subtracting 6x in order to set the whole thing equal to 0. So we have 4x squared minus 6x equals 0. From here, I once again need to find our greatest common factor. 4 and 6, the greatest common factor is a 2. And x squared and x obviously both share an x, so we're able to divide an x out. We then write it as 2x times 4x squared divided by 2x. 4 divided by 2 is 2. And x squared divided by x is x. Negative 6 divided by 2 is negative 3. And x divided by x is 1, leaving us with a negative 3. Now we need to set each factor equal to 0. 2x equals 0, and 2x minus 3 equals 0. Well, divide by 2, we get x equals 0. That one was pretty easy. And for the other one, it's going to take us a couple of steps because we need to get our 2x term alone by adding 3 to both sides. So we have 2x equals 3. And then we divide by 2, again, our opposite operation, to give us x equals 3 halves, or x equals 1.5 if you prefer. Generally, I personally prefer fractions, but honestly, it doesn't really matter. So there we go. We have our 2 solutions. This one, we had one extra step needing to get everything on one side so we could factor it. But outside of that, pretty straightforward. Now, when we have these 2 x terms, the x squared and the x term, we must factor. However, if we only have an x squared term and there's no other terms with an x, we're actually able to take a different tact. But first, I'm going to remind you of what we did before, which is we factored something like this to find our zeros or solutions to this one. So let's look at 3x squared minus 27. We got a whole lot of space to work with this thing because it's going to take a little bit of work. Now, the first thing I'm going to do is I'm going to look for a greatest common factor. And 3x squared and negative 27 share a 3 because 3 goes into 3 and 3 goes into negative 27. Now, normally, I'd have to worry about carrying the 3 around while we're factoring this because in most of these problems, we just factored it. But in this particular one, we are actually solving. So we can just divide the 3 out. because it won't end up changing the solutions to this equation. So 3x squared divided by 3 gives us x squared, negative 27 divided by 3 gives us negative 9, and 0 divided by 3 gives us 0. And from here, we need to factor this. And unfortunately, this is not going to be super pretty, because as you recall, x squared plus 0x minus 9 equals 0. That is because we are thinking about ax squared plus bx plus c. And in this example, a equals 1. B, which was not previously present here, equals 0. That's the reason why it wasn't there. And c is equal to negative 9. A times c equals negative 9. B equals 0. The numbers which multiplied to make negative 9 and add to 0 are 3 and negative 3. So we need to split up 0x into x squared plus 3x minus 9 equals 0. And then we need to find the greatest common factor of each pair. Greatest common factor of x squared and 3x is x. And the greatest common factor of negative 3x and negative 9 is negative 3. We rewrite it as x times x plus 3 minus 3 times x plus 3 equals 0. And then we write it as our final answer. The parentheses each become their own term, x plus 3. And the leftovers, x minus 3, become the second term. And we did all of that work just so we could get in a position so we can then solve for x. Now, thankfully, solving for x here, which I'll go ahead and put in this box down here, is not going to take too much effort because we have x plus 3 and x minus 3 equals 0. So we subtract 3 from both sides, we get x equals negative 3, and we add 3 to both sides, and we get x equals 3. Now, obviously, there are some shortcuts you can take when you're working through a problem like this, since it is a difference of squares. And it's quite possible that you looked at this step right here and you were just like, oh yeah, x equals 3. 3 squared is 9, and 9 minus 9 is 0. So that's one solution. And then negative 3 squared is also 9. So 9 minus 9 is 0 once again. And that's another way you can approach this problem if you just want to get it done quickly. But the long way and the fail-safe way, if in case you don't end up seeing the solution or we can't divide out the first, the a value attached to x squared by factoring, is to do this whole long process. And our goal is to find an easier way and a faster way, and that's what we're going to learn today. And we're going to find the zeros and solutions to this problem without doing that. So when we start with 2x squared minus 32 equals 0, first thing we need to do when we're going to find the solution using square roots is we need to isolate the x squared term. So we're going to add 32 to both sides, leaving us with 2x squared is equal to positive 32. From here, just like when we solve for a regular x, like if this had been 2x minus 32, we need to divide by 2 in order to get our x squared alone. So 2 divided by 2 leaves us with x squared, and 32 divided by 2 is 16, aka half of 32. Now from here, the last step we need to take is we need to take the square root of both sides. And the square root of both sides looks like this. This is the second root because it's undoing the second power. And we need to have the square root of each side. So we take the square root of each side and we end up with x is equal, well, what's the number that you multiply by itself to make 16? Well, what's the number that goes into 16? Let me think real fast. 4 and 4. Oh, that was convenient. 4 times 4. So I get to take 4 out. We have x equals 4. And you might be saying, well, that was really easy. That hardly took any effort at all. All we needed to do is just think about what number multiplied by itself makes 16. Well, I knew that from my multiplication tables. No problem. Now there's a problem though. And that problem is that we only have one solution. And if you look at the previous problem, we were sitting at a similar step right here, and we ended up with 2 solutions. So what's going on here? Well, what's going on is that x squared actually has 2 different numbers which you can put into it, which will make the square root of 16. or we'll make 16. And that is positive 4 and negative 4, which can be written as x equals 4, x equals negative 4, or x equals plus or minus 4, this being the plus or minus symbol. When you take the square root of something, or the fourth root, or any even root, what you need to worry about is that both the positive and negative numbers will satisfy the original statement. And if we look at this, if you think about it, we just go to x squared equals 16. We plug our solutions back in. 4 squared, of course, equals 16, because 4 times 4 is 16. But recall, if we plug in negative 4 squared is equal to negative 4 times negative 4. And a negative times negative is a positive, meaning the answer is positive 16. So the moral of the story is when you square root both sides, you should expect to have 2 solutions on the other side. We will explore instances in which something might go wrong, but you should expect to have 2 solutions. So you should end up writing in this plus or minus because you're going to end up with both positive 4 and negative 4. But I would say it's a heck of a lot easier to remember. We need to have a positive and negative 4 here than it is to go through all of these steps in order to arrive at the same conclusion, because we could have just cut it off at this point and said, well, add 9 to both sides, take the square root of 9 plus or minus 3. We're done. So let's go ahead and apply this using the questions in Canvas.